All right, so in these questions, we'll be looking at solving trigonometric equation when you have multiple angles. So for example, we want to solve this question, which is tan 3 theta is equals to what? Is equals to √3. So we're going to treat it the same way. There's not much difference. This we know that we are either in the first or in the third quadrant, right? But find our reference angle. So what is reference angle? Our theta star is still nothing but what? But pi, but 60 degree, right? It's because tan 60 is √3. So, but here now, what we're going to do is once we are in the first quadrant, we're going to say our 3 theta, because here we are dealing with we're dealing with 3 theta, not just theta. So our 3 theta in this case is going to be the same as our reference here, which is 60. Then remember, this is tan, so we're supposed to add what? K pi, right? We can add K pi. Then theta here, what is theta? It's just going to be, divide both sides by 3. This will be 20 plus what? K pi over 3. Right. So that is what is coming from the first quadrant. But if you are in the third quadrant, our 3 theta now is going to be what? Remember, in the third quadrant, so let me not use pi here. Let's just use 180K. So it will be 180 divided by what? By 3, which is just going to be 60. That's going to be 60K. See, this means that what here, it means your theta is just 20 plus what? 60K. So in the third quadrant, this will be theta. Then what? Your 3 theta is going to be, remember, this is our reference. And to get the standard, what do? We add 180 to this one, right? So this will be 240 plus 180K as well. And here we can divide by 3. So if you divide by 3, this will just be 80 degree plus what? 60K as well. So let me write it in this direction. Okay. So what will be our solution? Our solution set, we are interested from 0 to 90. So it means we're going to have 20 and what? And 80 only. This will be the solution. And that is when K is equals to what? When K is equals to 0. Right? So when K is equals to 0, because we cannot take K to be 1. It will be beyond the range. All right, so if you look at this one is 2 sine squared cosine squared minus 1, right? So let's see this one. So here we can also we can factorize, right? We can take what can we take as a subject of the formula? All right, so here, what can we do in this question? We can try to factorize first. So over here we can take cosine as a common factor. So we will have cosine theta as a common factor. So we have cosine theta, and this will be 2 sine squared theta minus 1. is equals to 0. But what is this one? This is like, we know that we know cosine 2 theta, it's 1 minus 2 sine squared theta, right? So what that means is that here we can factor out minus. So this is minus cosine theta. So that here will become 1 minus 2 sine squared theta is equals to 0. Because by the time you take this minus inside, you will come back there. But we can even cancel this minus since we have 0 on one side. So this is just cosine theta. And what is inside here? Inside here is nothing but cosine 2 theta. So it means you have cosine theta equals to 0, or cosine 2 theta is equals to 0. Yeah. So what is cosine theta equals to 0? This means theta has to be pi over 2 plus what? Plus n pi or k pi, right? And here also it means that 2 theta has to be pi over 2 plus k pi. Now these are the zeros, we can add 2k pi. So here it means that theta is just going to be pi over 4 plus k pi over 2. And here also it means that theta, here theta is already fine, so we don't need to multiply anything here. So this is just our solution. But we're looking for solution between 0 and 2 pi. So as you can see, if we substitute k is equals to 0 from this part, we will have pi over 2. From here, we'll have pi over what? Over 4. Now, can k be equals to 1? Yes. If k is equals to 1, k is equals to 1, from here we'll get 3 pi over 2, right? Now, if k is equals to 1 here, we're going to have pi over 4 plus pi over 2, right? And now this is going to be pi over 4 plus, if you multiply this by 2, you have 2 pi over 4 as well. So this is going to be 3 pi over 4. Now, can we take k to be 2? If we take k to be 2, this will not happen. It will be much more. And here, if you take k to be 2, if you take k to be 2 here, what will happen? 2 will cancel 2, so you will just have pi plus, so this is what we'll have. And that will give us 5 pi over what? Over 4. All right, so I think that is the best we can have. If k is 3, or if k is 3, if k is 3, this will become, this will be much more than. But here, with k is equals to 3, you can have pi over 4 plus what? Plus 3 pi over 2 here. And now this we can multiply by 2, so you have pi plus 6 pi everything over 4. So you can see this is still okay. This will give us 7 pi over 4. 7 pi over 4. And I think that is the best we can get. If k is equals to 3, if k is equals to 3, that is where we got this one. This is for k is equals to 2. This is for k is equals to 3. We have 7 pi over 4. And if k is equals to 4, definitely here we can't get anything, we can't get anything, we can get. So these are the possible solution here. So here we cannot take k is equals to 4. If you take k is equals to 4 in both ways, our answers will be out. So the solution sets are simply pi over 2, pi over 4, 3 pi over 2, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so let's move to the next question, which is cosine. This has to do with half angle, right? We have cosine squared. Okay, you have 2 cosine theta all over 2. So similarly, we're going to approach it in the same way. But now, knowing that we're dealing with half angle, right? Not so this we can rewrite it as what? 2 cosine theta over 2 is equals to root of 2, right? And that means that cosine theta over 2 is what? Is just root 2 over 2. So how do you treat this? So treat this as usual, either the first or in the fourth quadrant. So if you are in the first quadrant, but we know the reference, right? What should be the reference? Theta 1 is going to be pi over 4, right? So it means that if we're in the first quadrant, our theta over 2 is still going to be pi over 4 plus what? 2k pi. And now, what does that mean? That means that theta itself, you have to multiply both sides by 2. It's going to be theta over 8. You multiply by 2, it's going to reduce. So it's going to be theta, going to be pi over 2 plus what? Plus k pi. So we're multiplying both sides by 2. So this will be 4 k pi. Then if we are in which quadrant? In the fourth quadrant, we will have still theta over 2 is equals to what? Fourth quadrant is going to be what? Is going to be 2 pi minus pi over 4. So this is going to be 7 pi over 4. Then we can add 2k pi, right? So this means that what theta is, now we multiply both sides by 2. To get theta, we multiply both sides by 2. This will be 7 pi over 2 plus what? Plus 4k pi. But now we need only the thetas that can be 0 from 0 to 2. If k is 0, we'll have pi over 2 and 7 pi over 2. I think these are the only possible solutions. So we will have pi over 2 and 7 pi over 2. All right, so here, what can we do here? We can say this is cosine squared 2 theta minus 2 cosine 2 theta, okay? This also is going to be, it's more like a substitution because we can write this minus 3 equals to 0. So here something is missing. This is going to be between 0 and 2 pi. So we will do substitution. U now is going to be cosine 2 theta. So you'll have u squared minus 2u minus 3 is equals to 0. And this is going to be u minus what? And u plus 1, right? Now, once we have this, so what can we do? Here we can just say, okay, u is equals to 3 or u is equals to minus 1, right? Minus 1. Yep. So here something is happening here. We have to reject this one. Okay, come back here. I think I've seen something. What is the range? We need from 0 to 2 pi. So this has to be rejected actually because this is 7 pi over 2. So the solution should just be pi over 2. So this has to be rejected. Okay. Now let's come back here. So what is u? U, remember, is cosine. So we have cosine 2 theta is equals to 3, or cosine 2 theta is equals to minus 1. But we know that this is impossible because 3 is not in the range of cosine. That is why we reject, yes. Now we have only this one, and what is this? Cosine 2 theta is minus 1. Remember, minus 1 is, what is cosine minus 1? What will give us minus 1? Which angle? Cosine 180. Cosine 180 is minus 1. So it means that you can say that your 2 theta is just going to be 180 plus 2k pi. Remember, if you have cosine theta is equals to minus 1, we will say that theta is what? Is pi, right? Which is the first one, plus 2k pi. But now you don't have theta. What we have is 2 theta. So that is why we have to write that 2 theta is equals to pi plus 2k pi. So from here now we can solve for theta, which is just going to be pi over 2 plus what? Plus k pi. And here we can take how many k's we want, depending on the interval we have. So you can see if k is equals to 0, we're going to have pi over 2. If k is 1, we will have what? We'll have 3 pi by 2, right? Yep. So we'll have 3 pi by 2. Now, if k, what if k is 2? If k is 2, then it's going to be more than. So we have only 2 solutions. K cannot be 2. So we have only 2 solutions. When k is 0, we have pi over 2. And when k is 1, we have 3 pi over 2. All right, so that is the end for this video. We will look at another section, which is solving trigonometric equation involving inverse trigonometric function. Thank you for watching.